This is section 2.3, part 2. I want to work this problem here. The first thing we need to do is we need to distribute because we need to simplify both sides. So I'm going to multiply everything here by a 3 and then everything here by a positive 2. 3 times 6 is 18. Minus 3 times 4 is 12, so that is 12x. Is equal to 2 times negative 6x. 2 times negative 6 is negative 12x. 2 times 9 is 18. Now, you might notice something weird's happening here. You might not. So let's just keep going and see if we can figure out what's going to happen. We've got each side simplified. We're not allowed to combine anything because we don't have like terms on either side. Now we need to try to get our variables on the same side. So I want to move either the minus 12x or the minus 12x. These are looking pretty similar. Let's try moving this over to here. I'm going to add 12x to both sides. And what happens? Well, that cancels out because I wanted it to, but this also cancels out. And now I have 18 equals 18. I don't have a variable anymore. So something weird has happened, and it's not something to be scared of. When your variable goes away, our variable canceled out, so that means we have something unusual happening. We will either have all real numbers, which means that every single number you can imagine, you can plug in for x and it would be correct, or no solution at all. So there's nothing you could plug into x and have it work out. The way you decide whether you have all real numbers or whether you have no solution is you look at what you have left and ask yourself, is this true? Does 18 equal to 18? Yes, it is true. So we have all real numbers. Every single number you can imagine to plug in here will work out. Okay? You will see all real numbers. There's also this symbol that you may have seen before. It looks like a weird R. In a textbook, that would be a bold capital R. This particular symbol is called blackboard bold because it is impossible to write a bold letter on a blackboard, so they developed this kind of notation to indicate that. But it does mean that any number you can imagine, you can plug in and it will work. Okay? So that is all real numbers. Let's try this problem here with some fractions. Now, first of all, fractions are perfectly legitimate numbers. I have like terms here. I could subtract those fractions and get, find the answer, get a common denominator, do all my arithmetic, and work everything exactly the same way I would if they were just regular, nice, pretty numbers. It will work out. We talked a bit in 2.2 about how to multiply both sides by the reciprocal. That works when you have just a single fraction in front of a single variable on a side next to a number. So if these two parts weren't there at all and I had 3/5 t equal to negative 5/2, I would multiply both sides by the reciprocal and I'd be done. I'd be quick. Over done with. This one's not quite so easy. What we can do is we can clear out the fractions. I call it killing the fractions. What we do is we figure out what our least common denominator would be for every fraction that's in the entire problem. So here I have a 5, a 10, and a 2 in my denominators. I need to find the LCD. What you do, the easiest way to do it is to find your largest denominator, in this case, which is a 10, and ask yourselves if your other denominators divide evenly into that. 5 does divide evenly into 10. 2 does divide evenly into 10. So my LCD is a 10. if it did not work, so if one of these did not divide into 10, I would take the 10 and multiply it by 2 to get 20 and see if 20 worked for both of the other two. If it did, my LCD would be 20. If it didn't, I would take the 10 and multiply it by 3 to get a 30 and then see if that worked. And I would keep multiplying by 2 and then 3 and then 4 and 5 until I finally found one that worked for everything. My LCD is 10. What I want to do once you find that LCD is you want to multiply every single thing by that LCD. Now the important part here is I'm not just going to multiply these fractions by a 10. I'm also going to multiply that understood 1 right there by a 10. Okay. 10 is the same thing as 10 over 1, right? I'm going to write it as a 10 over 1 when I'm multiplying a fraction. I'm going to write it just as a 10 when I'm multiplying the whole number. So I have 10 over 1 times 3/5 t minus 10 over 1 times 1/10 t equal to 10 times 1t minus 10 over 1 times 5 halves. Now, if I've done this correctly, every single denominator should go away and I shouldn't have any fractions left. All right, so let's look at multiplying these two fractions. The 5 and the 10, remember when you're multiplying fractions, you can either multiply straight across and then reduce, or you can reduce on the diagonals before you multiply. It's called cross cancellation. The 5 and the 10 will reduce. If I divide the 5 by a 5, I get a 1. Divide the 10 by 5, I get a 2. Now I have 1s on the bottom, which means I don't have to write it because I don't need to keep a 1 in the denominator. I have 2 times 3, which is 6. So this is 6t minus. For this one, my 10s both cancel out. If I divide both of them by 10, I get a 1. These are exactly reciprocals, so of course they multiply to a 1. And that gives me a 1t equal to 10 times 1 is 10. 10t minus the 2 and the 10 will reduce. If I divide this by a 2, I get a 1. Divide this by 2, and I get a 5. 5 times 5 is 25. So 3/5 t minus 1/10 t equal t minus 5 halves is exactly the same as 6t minus 1t equal to 10t minus 25. This is a problem, no fractions. We know how to solve it. Let's combine like terms here. 6t minus 1t would be 5t equal to 10t minus 25. Now let's get our variables on the same side. Since I only have one constant, I really want to move the 10t over to the left. Since I'm moving it across the equal sign, I'm going to subtract 10t from both sides. And I'm going to write this up over here. 5t minus 10t will be negative 5t. That cancels. I have negative 25. Now, I left out the equal sign. That would help. Negative 5t equals negative 25. Yeah. Now, that's a multiplier. I need to get it away. So I divide both sides by a negative 5. Remember, when you're trying to undo a multiplication, we're actually trying to create a positive 1. So we match the signs. Negative 5t divided by negative 5 is positive 1t, or just t. Negative 25 divided by negative 5 is a positive 5.